Although the burning of fossil fuels is an essential source of energy, a consequence is flue gas, gases from the combustion reaction exiting from flues of power plants worldwide. It is composed mostly of nitrogen gas and carbon dioxide, but major pollutants are sulfur dioxide and nitrogen oxides, the primary causes of acid rain and several respiratory problems. The problem was severe. In 1990, the amendments of the Clean Air Act included a reduction of sulfur dioxide levels of 10 million tons by 2000, and a decrease in nitrogen oxide levels from 53 parts per billion. Major contributors were power plants, which today, for comparison, produce 14,000 tons of sulfur dioxide and 10,000 tons of nitrogen oxides. If untreated, effects can be harsh. In 1980, the average sulfur dioxide level was 150 parts per billion, which damages some vegetation. But if it were to increase, effects would worsen, and odors would be prevalent. Also, climate change would worsen, as 1 pound of nitrogen oxides is 300 times more effective in warming the atmosphere than 1 pound of CO2.
As energy demands increase, it isn't feasible to restrict power plants to a very high extent. Thus, flue gas desulfurization was invented in the 1930s. There are a few types, such as wet scrubbing, where the flue gas is in contact with an alkaline liquid to remove pollutants, and dry scrubbing, which does not use moisture. However, we will discuss a recent invention in the mid-90s by a company called Haldor-Topsoe, the SNOX process, which stands for sulfur nitrogen oxides. We have chosen the SNOX process because it is more efficient, cheaper, more versatile, and does not use water. However, it is relatively unproven, with fewer plants worldwide, but with much greater potential. The research question is, to what extent does the SNOX process aid in the reduction of airborne pollutants in the atmosphere and improve health conditions of people?
The SNOX process starts when petroleum, coke, and other fossils combust with oxygen in the boiler. The products of the reaction between the hydrocarbons in the fossil fuels and the oxygen include harmful compounds such as nitrogen oxide and sulfur dioxide, which are released as flue gas. Next, the fine dust particles of the flue gas are removed by an electrostatic precipitator. First, it passes through an electrode that gives the dust particles a specific charge. Then, these particles pass through a second electrode that has the opposite charge, attracting the dust particles. Then the gases are heated to 100 degrees Celsius in the heat exchanger to make it easier for reducing agents to react with the gases.
Then, in the SCR-DNOx reactor, the nitrogen oxides in the flue gas are reduced. Ammonia, the reducing agent, is injected into the flue gas using catalyst material, which doesn't react. When the ammonia has reacted with the flue gas, the products yielded are nitrogen gas and water, which can be released into the environment as they are safe. Following this, the sulfur dioxide needs to be removed. After passing through the DNOx reactor, the flue gases enter the SOZ converter. In this apparatus, the sulfur dioxide reacts with the oxygen gas to produce sulfite. Once sulfite is yielded from the reaction, it is then reacted with water to create sulfuric acid in gas form. Now that the harmful substances have been removed, the flue gas is then passed through an acid condenser so that the gaseous sulfuric acid produced can be retained in liquid form. By cooling the flue gas, liquid sulfuric acid remains on the walls of the condenser, which can be resold, while the now clean and free of pollutant flue gas rises upwards.
SNOX is more efficient as it removes 95 to 99% of sulfur dioxide and 90 to 95% of nitrogen oxides, whereas scrubbing processes remove only 90% of both. Scrubbing processes saw a 62% and 29% decrease in national sulfur dioxide and nitrogen oxide levels respectively between 2000 and 2013. An upgrade, the SNOX process, would garner even better results. The greatest benefit is little to no waste is produced. All byproducts can be released safely into the environment. Also, the liquid sulfuric acid can be sold to recoup costs. This is in comparison to the limestone and water waste the scrubbing produces, in addition to several corrosive acids.
Also, SNOX is economically beneficial as the average cost is $69 million compared to the $76 million of the scrubbing process. It also saves costs for other waste gas facilities as it can refine hydrosulfuric gas and use the Klaus process to remove sulfur. However, SNOX is relatively new, which removes established power plants off the buyer market. Also, it is proprietary and can only be purchased through Haldor-Topsoe, thus discouraging potential buyers as they cannot implement it independently. To summarize, the SNOX process would be very effective in reducing pollutants, but the barriers lie in its possible implementation. The purpose of SNOX is to reduce the amount of pollutants in the atmosphere, so it must be judged on how it affects the environment, including ecosystems, water sources, and animals. Sulfur oxide levels will decrease more than 68% from 2000 and nitrogen oxide more than 29% from 2000. This will greatly decrease the amount of acid rain and preserve many ecosystems. In addition, it would help preserve vegetation and reduce climate change as the amount of nitrogen oxides would lessen. However, this may serve as an excuse for factories to continue burning fossil fuels excessively, as they claim the SNOX's benefits as an excuse. However, CO2 is still massively produced. A typical coal power plant produces 3.5 million tons of CO2, accelerating climate change.
As the purpose of the SNOX process is to reduce pollutants in the atmosphere, we must judge how it benefits the health of the people in surrounding areas, which would be the stakeholders in this context. Nitrogen oxides are harmful to breathe in, causing asthma and other respiratory problems. Also, if it reacts with ammonia found in nature and other compounds, nitric acid particles would form, potentially resulting in lung tissue damage. Sulfur dioxide is similar, but with the potential to aggravate heart diseases. The SNOX would reduce these possibilities. As mentioned previously, excessive burning of fossil fuels can result in excessive CO2 levels, thus contributing to climate change and affecting the inhabitants of the world.
The SNOX process very effectively reduces pollutants in the atmosphere, benefiting both the environment and the health of affected people. To summarize, the SNOX process is more efficient than other methods, more economically beneficial, versatile, and improves the conditions of the environment and the health of people.
However, it may prove hard to implement as companies do not wish to buy proprietary products, and many have already implemented scrubbing techniques. In conclusion, the SNOX process will have a positive impact on the environment and health of people through its proven, efficient removal of pollutants.